Okay, we're in section 3 of the notes, and this is the lecture portion of it. And by lecture portion, what we're going to do is we'll go through a tiny review of what you've done in math 121, which is the area between two curves. It's one of the applications of integration. All right, so the bottom line what I'll do is I'll talk through this. I'm not going to read it verbatim to you, but I will talk through this. We do provide good pictures for you for a reason. We'd like you to look at those pictures. But your goal is to create your own pictures. They don't have to be this detailed, but that's your goal, to create these pictures over here. All right, so we'll go through it in the blue area again. There's a little work over here for you. I'll certainly go through that work. We'll go through this example. We'll talk about a good picture over here. And certainly this is something that you want to be able to do on your own. So, I'll do another example and then we'll go to examples. But first, a little tiny mini lecture to try to, whet your appetite for seeing what examples would look like at the level that we're teaching. And then you're going to get a chance to try on your own by doing the homework that we assigned for you. All right, so let me go back to the whiteboard. And I got to do another share with you. And give me a second here. And again, we're in the lecture portion. So this over here, I want to point out to you the way we like you to try to do these problems over here is, one is try to understand what you're reading. So it does say the material is covered in Math 121, but that's part of what we do at Essex. We, especially in the lower level courses, we do a lot of repetition. We repeat, like for example, Math 100, we repeat, it seems like, maybe 2 months worth of the 092 material, Math 100. Now, when you get to Calculus 1, we really don't do that much repeating of what you've done in pre-calculus. We might say it's a good idea to review, but then we get to Calc 2, there is a slight overlap. The reason for that is not everyone in Calc 1 goes at the same pace. And towards the end, a lot of students actually shut down and they can't remember that they did this, but it is part of the syllabus, all right? So anyway, what do they want to do? Suppose you're asked to compute the area between, f of x, and I'll outline this for you. And they want to know that this is f of x equals minus sine x. And the other one is this one over here, this one over here. So my goal over here is to visualize this, and they want me to go between 0 and pi. But before I do that, I want to visualize, where's minus 2 sine x and minus sine x? Well, I'm going to visualize it for you, and I'm going to just trace it in for you. So this is the curve. And again, I'm visualizing minus 2 sine x. And this is the curve minus sine x. I'm going to put down a points of intersection now. They're over here. And again, we have a visual. And what's a visual over here? Well, this is going to intersect at the point pi, comma 0. And this point over here is 0, 0. Now, where'd you learn to graph trig functions? In Math 120. Now, what am I going to do? Well, they want the area. So I clearly see this is shaded in for me already. So I'm going to put a rectangle in, and my rectangle is going to look like this. The reason I do that, I want to tell you about the differential, which is dx. All right. So I'm going to put my integration done now. What's the integration going to be? Well, it's going to be it's along the axis from 0 to pi dx. So I got the thickness, but I don't have the height of it. What's the height of it? It's the upper curve minus the lower curve. What's the upper curve? It's minus sine x minus the lower curve. What's the lower curve? Minus 2. So it's going to be plus 2 sine x. All right. So what do I have to do now? This is going to be the area enclosed by that region. So it's going to be 0 to pi. I want to recommend simplify the integrand. And it's pretty simple. It's sine x dx. I'm going to take the antiderivative now. And again, as an antiderivative, you should recognize from Math 121, what differentiates the sine? Minus cosine of x. Limits of integration, 0 to pi. Again, you're expected to do any kind of numerical stuff you can do. I'll give it a try. Minus cosine of pi, that's the upper limit, minus a minus, which is plus cosine of 0. Well, you should know the cosine of pi is -1, and minus a -1 is +1, and the cosine of 0 is 1, and 1 plus 1 is 2. This worked out pretty nice. All right. What am I going to say? Do I make mistakes? All the time. But what do? We tell you the answer. and the work is written down for you. All right, the work is written down for you. Now, by the way, someone says, oh, the chicken scratch wasn't written down. Yeah, we're doing the chicken scratch whiteboard for you. Now, of course, when it's typed up, that's what it would look like. And that's what it looked like in a textbook too. All right, this one's a little more challenging. And I'll tell you why it's more challenging for students is the graph can be a little difficult. But what I want to do is I want to look at it before I look at their good picture. I want to get a better idea what's going on over here. And so I'm gonna try to visualize this. So there's two curves. One is f of x equals x squared. I know that's a parabola. And the other one is g of x is a cubic. And I know a cubic sort of like this over here. All right, just rough picture. Then get my eraser out. I can't just do that rough picture. I got to do a little more accurate than that. Let me get my eraser out, erase this over here, and erase this over here. And what I'm going to do is I'm just going to try to find out the points of intersection for this over here. How would I do that? Well, it's something you learned in Math 119. I'm going to set them equal. So x squared is equal to x cubed. Well, 0 equals x cubed minus x squared. I'd factor that. That's x squared, x minus 1. So I know there's a point of intersection when x is 0. We'll get the point later, by the way, and when x is equal to 1. So plug it in any equation, whether it's x squared or x cubed. Well, if I plug in 0, I get 0. If I plug in 1, I get 1. So now I know there's 2 points of intersection. I'm going to draw my parabola. F of x looks like this. And it's got hit the origin, right? This is where some students are going to really struggle with the problem. And I got to do that x cubed, but I'm going to go only between -1 and 2. This is -1. This point over here would be -1, 1 along that parabola, and then 2 is over here. And what would that point over there be? It would be 2, 4. That's not so bad. All right. And by the way, I got points of intersection. I want to point them out to you at 0, 0, and the other one's going to be at 1, 1. These are points of intersection. I can put the cubic in. I know what cubics look like, sort of. And a cubic's going to look like this over here. Let me extend this line. I got that part covered. And what's this point over here? Well, that's going to be -1. Whoops, that doesn't look right. -1. All right. I definitely see the region there. Here comes my problem. I know there's something, and it's a cubic. I hope you start to realize the cubic between 0 and 1 is going to be below the quadratic. It looks something like this over here. And then when it hits 1, it's going to overtake. It's going to go up like this. It's going to hit up here somewhere. Now, where's that? I got to put that down now. It's going to be at 2, 8. Let me do a little shading for you. Oops, sorry, I got shader. I got to do this region, and then this region over here. One region at a time. Let's go for it. First region. Whoops, let's go back to black ink. Starts at -1. Oh, by the way, my rectangle looks like this. So it's a dx problem. Starts at -1, and then it stops at 0. That's the first region. What's the upper limit? It's a quadratic. It's x squared. Whoops, didn't mean to do that. What's the lower curve? It's the x cubed problem. Let's do the next one. The next one starts at 0, and it stops intersecting at 1. What's the upper curve? It's still x squared minus x cubed dx. Plus, what are we going to do now? We're starting up at 1, and we're going to 2. Again, let me point out what we're doing. We're going to 2. What's the upper curve now? It's x cubed. What's the lower curve now? X squared dx. All right. Now that's our integrations, and let's see if we can do it. And again, I know it looks tough. I really do. We got to do it though. And I'm going to do it one step at a time. X cubed over 3 minus x4 over 4, limit integration -1 to 0, plus x cubed over 3 minus x4 over 4, limits of integration, 0 to 1, plus x4, I know it's a lot of work, we're encouraging that, minus x cubed over 3, 1 to 2. Well, I got to do my work, all right, one step at a time. Let's do this one first. 0, upper limit, lower limit, minus 1/3, minus 1/4. That's this guy done. Let's go to the next one. 1/3 minus 1/4, lower limit 0. That one's done. But I would say it's done right now. I'm not done with the arithmetic. Let's do this one over here. What's that going to be? 2 to the 4th is 16/4, minus 8/3. That's the upper, minus the lower. That's 1/4 minus 1/3. And again, I notice a lot of work. You know what? I'm just going to clip things off. 0, 0. That's done. Let me do the thirds now. This is plus 1/3, 2/3, minus 5/3, right? Minus 5/3, plus 1/3, 4/3. I'm not beyond making error though. Let me point out what I did over here. 1/3, 2/3, minus 6/3. Oops, I made a mistake. I gotta erase that. I don't know how I did that. Let's do that again. 1/3, 2/3, minus 6/3, minus 5/3. I got to do that again. 1/3, 2/3, minus 6/3, minus 5/3. Okay, I did that all right. Let me do the next one. 1/4 minus 1/4 is none. 16/4, 15/4. Yep, I know it's tough. 12, common denominator. Minus 20 plus, let's see, that would be 3 times 15, 45, right? That's going to be 25 twelfths. All right, let's see how we did. We got it. Now, by the way, you may be confused what I'm doing over here, and that's part of it, part of your learning curve. I put this down over here. That's fine, but I'll be honest with you, doing an integration with absolute value on it is simply out of the question. So I had to rewrite it. And so it says, where did this one come from? If you notice over here, these two can be combined into one. They have the same integrand. So what do I do from -1 to 1? That's where that came from, right? What's the last one going to be? Well, that's the last one we did. What's the problem over here? For a lot of students, it's setting up the integral. That's the big problem they have. The other big problem is just simple arithmetic. I make mistakes too, but generally speaking, the integration takes more precedence than the arithmetic. Here's the deal though. If you get a bad integration, arithmetic's not going to help you out of it. It's not going to help. All right. Let's go to the next example. This one over here. And again, I want to point out to you that this is a problem where they say compute the area. I got to visualize this. They give me a picture. I'm going to visualize for you. I got this one, and I got this one to visualize. Which one of those two curves you think might be easier to visualize? I'm going to say the blue one. That's a parabola. And what's parabola look like this over here? All right, we'll talk about it in more detail later. The next thing I'm noticing about this one over here is the red curve is a is a fifth root of x plus 1. And I think I know what that looks like. So I'm going to put that down for you. I got to be honest with you, though. The points of intersection would be incredibly difficult for me to put down by using algebra. So I actually used a machine to approximate them. And I want to go through that with you. I want to talk about this point here. It's a green point. And where would that point be? Well, it's right over here. That's that point. I'm going to put the other point down. And these are given to me. It's this point over here. Now, someone can say, I don't trust them. I want to do my own. We don't mind you doing your own. You can do your own. So here comes my problem over here. I got to figure out how to do the problem. So someone can say, I don't even know where to start. Well, I know my limits, whether I'm going dx or dy, right? For example, if I go along the axis of dx, it would start here and it would end there. If I were doing a dy problem, I would start here and go there. Here's my problem. This one is solved for x, and this one is solved for y. So which one of these two would be easier to solve for either x or y? I'm going to say the red one is going to be really easy to solve for x. I'm going to make an attempt to do that. And I'll write that down for you. There's going to be y equals the fifth root of x plus 1. And I want to see if I can solve for x. What do you get over here? Y to the fifth power equals x plus 1, or x would equal, right, y to the fifth minus 1. All right. So I'm going to claim that this curve now is going to be called this one over here. All right. I prefer that. So what am I really looking to do? I'm looking for a dy problem now because I know my integrants in terms of y's. So I'm going to put this down now. I'm going to put my little rectangle down. It's a dy problem. This is dy now. I'm going to write that down for you. I'm not going to say it's going to be easy for you. dy. What's the limit of integration? Well, the y is going to start at minus 0.30349. No, I would not expect you to do arithmetic with that. What's the upper limit for the y? 1.26137. Let's get the integrand down. Upper minus lower. Well, the upper is the square problem. So what's it going to be? 3y minus y squared minus the lower one. What's the lower one going to be? Well, that's x equals y fifth minus 1. So I'll write this over here. All right. So if this is an exam question, I'm going to say for the most part, I guess I could do some of it. I hate writing those numbers down, by the way. Let's write this down. What do you get? Well, let's see. You get 3y minus y squared minus y to the 5 plus 1 dy. Well, if this is an exam question, all that I expect from you now is to write this down. Wouldn't expect any arithmetic though. 3y squared over 2 minus y cubed over 3 minus y6 over 6 plus y, limits of integration, gee, don't lose those guys, minus 0.30349, upper is going to be 1.26137. I would not expect arithmetic from you, this over here. Let me talk about arithmetic though, all right? Some of the arithmetic get really difficult. What I'm going to suggest you do is, and it even says, use a calculator, learn how to use a calculator. But let me see if I did this one and see if I got the right thing down. 3y minus y squared minus y5 plus 1 dy. Yeah. So someone's going to, oh, you didn't do the number. So throughout the course, what I'm going to do is introduce something to you. I'm going to introduce what's known as computer algebra system. So in this section of notes, you're going to see me do an integration using a computer algebra system, and you should learn that. The computer algebra system I'm suggesting you use is Sage. Why is that? It's free and open source. All right. So next up will be some examples. Then there'll be a chance for you to try, and I'll also give a presentation on how to do this on a calculator. And my calculator of choice in this class is Sage. Also, another great calculator of choice is Wolfram Alpha. That can also do it. And you should be familiar with how to use a computer algebra system by the time you leave Essex County College. Thank you for your paying attention, and good luck.